Today we're going to look more closely at the parent graphs of sine and cosine and get to know the features that are involved in each of those graphs. Some of these features are going to be familiar. Some of them are going to be new vocabulary for us, but we'll get it all in. So first of all, I just want to point out that my top graph is sine and my bottom graph is cosine. So some similarities there. Obviously, they both seem to be oscillating. They both go back and forth between -1 and 1. Sine starts at 0, 0. Cosine starts at 0, 1. So a lot of similarities and just a couple of differences between them. So let's look at these features more in depth. So first of all, domain. We remember that domain represents the inputs of a function. And since we have some arrows at the end of this, and if we think about what happens as we extend to the left and to the right, remember when we go to the right-hand side of either of these graphs, that means we're talking about more and more rotations around the unit circle. If we go to the left, we're talking about rotating in reverse or in a clockwise direction, excuse me. So our domain here is all real numbers, or we can use our all real numbers symbol to denote that. Our range, we remember, represents the outputs of the function. Now, if we look closely at both of these functions, they both have a maximum value of 1, right? They go up to 1 and not above it, and they have a minimum value of -1. So since those y values keep bouncing back and forth between -1 and 1, that's the limitation of our range. So our range here is we're going to say all the y values between -1 and 1, and I make that inclusive. I put equal to because it does actually equal exactly 1 or exactly -1. Our y-intercept, we're pretty familiar with that all the way back to 7th and 8th grade there. The y-intercept is the point where the graph crosses the y-axis. So for sine, our y-intercept is at 0, 0. For cosine, our y-intercept is at 0, 1. So I might just label those with my y-intercept. Okay. Our x-intercepts, you'll notice that both of these graphs have multiple x-intercepts, and they're equally spaced apart. For sine, if I just zoom in here, we've got an x-intercept at 0, 0, and then we have another one at pi, and another one at 2 pi. If we go backwards, we have one at -pi, and if we were to extend forward, we would have another one at 3 pi. So sine crosses the x-axis every interval of pi. So we're going to say that this has x-intercepts at pi, and maybe I'm going to use pi r. So we'll call this intervals of pi. Whereas cosine, since cosine doesn't start at 0, 0, if we look at where it crosses, the first time it crosses is at pi over 2. It doesn't cross at pi, right? But it crosses again at 3 pi over 2. And it crosses once more at 5 pi over 2. So that distance is still the same, right? That interval is still pi units in length, but it's a little bit offset from where sine was, and that's because of a different starting. If you're hearing some odd noises in the background, it's because my puppy dog has taken an interest in one of the cats, and the cat is not very happy about it. So the hissing and growling is totally normal. Don't worry about it. So we're talking about cosine here, sorry. So cosine, it will happen at intervals of pi halves plus pi r. So maybe I'll say intervals of pi starting at pi halves. So I'm not going to ask you to really explain those x-intercepts too frequently. I've done my best to explain them here, and if you were to search this, you would find some other ways to express this, to actually write it out. I'm not too worried about that. Mostly I just want you to be able to identify them from a graph and realize that they happen at a constant interval. So these next three words are kind of new terms for us here, especially now that we're looking at these sinusoidal graphs, but they're pretty common sense here. So let's define the midline, and unfortunately this might get a little bit squishy in here. Oh, that would be the dog. Oh. Hey, Louie. No. I apologize. There seems to be a Wookiee in the room. So our midline. Midline is defined as the horizontal line, excuse me, let me add to that, the horizontal center line about which the function oscillates above and below. So this horizontal center line about which the function oscillates above and below. So let's take a look at both of these graphs. Now the midline for both of these graphs is pretty straightforward to identify. If we think about, okay, a center horizontal line that the graph just goes back and forth across, for both of these graphs, it actually happens to be the x-axis. Now, when we start to transform these graphs, just like we've transformed other functions, we'll see that midline will shift. But for these parent graphs, our midline is at the line y equals 0, the x-axis. So that's something to just keep in mind. But again, that vocabulary word is pretty self-explanatory there. So amplitude is defined as the maximum distance the function ever reaches from the midline. So if we think of the midline, right, as kind of the center of the graph, the amplitude tells us how far away the function will ever get from that midline. So again, if we think about both of these graphs together, we'll see that from the midline, both graphs only ever go a distance of 1 unit above or below. Our maximum value is 1, our minimum value is -1, and a midline at 0. So in both of these cases, our amplitude, and let me make some arrows there, our amplitude is equal to 1. And so I like that word distance because it is automatically kind of a positive. We're not going to say the amplitude is positive and -1. We're just going to think of it as a distance. If we were to actually just measure how far does it get, either above or below, we would have a positive value of 1. So maybe I'll make a note there that our amplitude, oops, excuse me, is 1 for both functions, for both sine and cosine. Again, we might transform these later and change that amplitude. The last new term here is the period of the function, and the period is defined as the length of one cycle, whoops, try to combine words there, one cycle of the function or curve. So think of a period of time, right? The period, when we're talking about trig functions, is the length of one cycle of the function. So one way to think about that is it's the length of time it takes for the function to go from starting point to starting point. And if we relate that to the unit circle, it's like how long does it, or how far does it travel to have to go from the start, and back to that same position? Well, in a circle, that's a distance of 2 pi. So it makes sense here when we're talking about sine and cosine, that period is also 2 pi. If I trace it from that start at 0, 0, its full cycle stops again at 2 pi before it starts another cycle. So for sine, our period is 2 pi. That's the time it takes for it to go through a full cycle. Cosine, again, I'm starting kind of at the top of this curve, and I go down, I go down, I go down, and I go back and go back and back up to a point where I'm now about to start the process again. So just like sine, cosine has a period of 2 pi. So just a couple of new terms here, and I do think they're pretty self-explanatory. But just to start planting these seeds here before we start talking about transformations. So our x-intercepts occur. There's infinitely many x-intercepts, but they occur at specific intervals. The midline is a horizontal line that's right in the center of the curve. The amplitude represents basically the height of the curve from that center line, from the midline. And then the period is the length that it takes for the curve to go through one full cycle, or the distance until it starts the cycle over. So thanks for checking in. Take care of yourself, and let me know if you need anything.